Okay, so today I'm going to explain the traveling salesman problem. So before I start to explain, I'd like to say that when I'm uploading this on YouTube, in the description I will be adding the chapters on different levels of the explanation because I'll be explaining in detail. And also, if I could not record the whole session, uh, I will add the link for the second video in the description also. So do check the description. Uh, do check it. So first of all, in order to understand what is the traveling salesman problem, the first question which arises in our mind is what is traveling salesman problem? And also, we'll be having another question, that is why. Why do we need traveling salesman problem? So to understand why do we need it, we need to first of all understand what is traveling salesman problem. Then we will understand why do we need it. So as the name suggests, traveling salesman. So imagine yourself as a salesman who travels from a city to another city to sell his things. So basically, when you're traveling, you'll be starting from, let's say, you'll be starting from city W, and from there you will need to go for another three cities called X, Y, Z. Okay, so now you have to cover all these X, Y, Z cities from W. So the starting point is W, but you have to visit all these cities, for which you have multiple paths to travel. So you'll be having like these multiple paths to travel throughout. So when you select a particular path, the number of kilometers, let's say from W to X, it is 5. Um, from X to Z, it is 2. And Z to Y, it's 1. And Y to W, let's say it's 2 kilometers. So we'll be assigning random numbers at present. So, but when you're traveling from W to X, the distance might be 5. But as you can see, this is a double-sided arrow mark. That is, which doesn't mean that this is the same path. Means when you're traveling from W to X, the path might be 5. But from X to W, the distance might be different. Let's say it is 4. So in like this way, you'll be having different kinds of values for traveling in each particular path. So when you're traveling in a particular path, when you're traveling in a particular path, the distance might be different. So you need to select one particular path through which you will go through all the cities, that is from W to you will travel to all the cities X, Y, Z, and you have to return to W. Okay, so we need to find the shortest path in which you will cover all these X, Y, Z cities. So that is the traveling salesman problem. So now, how to solve this problem? That is, how to know the least path. How to know the least path in order to travel through all the cities. That's the solving method. So how do we solve it? Basically, we will solve this by using um, binary search trees. Let's say we'll be starting from W, right? So we'll be having three different options. From W, we can either go to uh, X or Y or Z. We have multiple options, right? So when you're traveling in each particular path, uh, don't be confused. These are the different paths. You'll be selecting any one of these. So let's say we have selected from W to X. Then X2, we have two another options. That is Y and Z. You might select Y or Z. If you select Y, of course, the remaining one is Z, and here the remaining one is Y. And accordingly, from Y and Z, we have different uh, options. That is, from Y, we will be having X and Z. From Z, we will be having X and Y. Uh, and this continues. After reaching the all the cities, you will need to return to W. Okay. This in this we will consider all the possible paths first. Then we will uh, what will okay, we will summation the distance between through these paths. So let's say from W to Z it is 2, and Z to Y it is 3, and Y to X it is 5, and X to W will be having 4. Like this, from each particular city to another city will be having different distance. So after we add all these distances, so from here to here it will become 5. Then 5 after 5 we will travel from 5 to X. So 5 plus 5 it will become 10. Similarly, when we travel from X to W, the total distance will be 14 kilometers. Let's say this. So similarly, when we go through all the different paths, uh, we will when we travel through different paths, the value will be different. So we will calculate all the possible distances, distance values, and we will compare all the distance values, and we will decide which one is shorter. So let's say from this shorter, we will get 14. Similarly, we will get uh, um, okay, we will get all the different values, and we will compare those values and decide which one is shorter. And we will select that path and we will display it. So that is the introductory part of this. So this is the way in which we solve it. But the problem is not solving like this. So we are solving using a dynamic programming, right? So what's the approach to solve this same problem using dynamic approach? So that's what the problem is all about. So now uh, we will look after that. Okay, so I'll consider one particular problem which I've already solved. Uh, uh, let's say the vertices are 1, 2, 3, and 4. But as I said earlier, you can observe here that from 1 to 2, the cost may be 10, but it's not the same for 2 to 1. So for 2 to 1, we have 5. Similarly, we will have different values. So how do we solve this using dynamic approach? For this, first of all, we will need to consider subsets of the uh, uh, what uh, of the all the possible vertices. So as we are starting from the the vertex uh, uh, let's say we are starting from vertex 1. So when you're starting from vertex 1, we have the possibilities as 2, we can go to 3, we can go to 4. So these are the possible values, right? So um, before we solve this, we'll be starting from the vertex 1, right? So we'll consider all the subsets from these remaining vertices, that is 2, 3, and 4. As you know, that for all these sets, the null set or phi, which is a null set, which this is the subset of all the sets. So first we will have the subset as null set. Then we will consider each individual vertices as uh, uh, the subsets. Then we will select the subsets with two of the uh, vertices. Then we will consider the subset with all the vertices possible. So now we will proceed with uh, solving this uh, solving this problem. So as I mentioned earlier, we'll be calculating the least path, right? So we'll be calculating the least path from 1 to 2, 3, and 4, visiting all the vertices. So give 1 minute. Okay. Let's continue now. So um, uh, after making all these subsets, we'll start making calculating the cost from each vertex to another vertex, which we'll call as a gross cost. Let's say we'll be calculating from 2 to vertex 1, and 3 to 1, and 4 to 1. Similarly, so that we will consider as the gross cost of 2 comma null set. That is because we are selecting 2 and only the vertex 1, the vertex 1, which is not in the set, of course. So it will become 2 comma 5. Similarly, for 3 and 4, we will um, get these values as from 2 to 1 it is 5. Similarly, 6 and 8, 4, 3, from 3 and 4. So this is the basic idea. I forgot to mention one thing, that how we will calculate this particular problem. So we have the ultimate goal here as g of 1 comma 2 comma 3 comma 4, right? This is where we'll be finally getting the value. So for this particular solvation, we have one what do we call it? We have one equation through which we will solve this. So the equation is g of 1 comma we will consider all the vertex minus the set 1. Why have we excluding this? Because as I said earlier, we'll be starting from vertex 1, right? So uh, from the throughout all the remaining vertices we will select. So that's why we'll consider that as um, all the vertices minus the vertex 1. So we'll be having the formula like this. So basically, as I said, we'll consider this as sorry. The gross cost of the gross final cost, which we will take as a minimum of cost of one cost of one and k from vertex 1 to vertex k plus the gross cost plus the gross cost of um, k comma what the all the vertices minus 1 comma k. So like this will be having the uh, formula. So this is the formula. This is the ultimate formula through which we will be calculating the final value. So uh, to achieve this particular uh, particular equation, we will need to, so particularly we will need to uh, find uh, these gross costs. So to get these gross cost, we will start from here. That's what the procedure is. So okay, the value of k here will be starting from 2 to n. Why 2, not from 1? Because we'll be starting from 1, right? So we'll have the set from starting from 2. That's another reason. So we'll be starting from 2 to n until we reach the last vertex. We'll be considering. So here, as you can observe, from vertex 1 to vertex 2, vertex 3, vertex 4, the k value will be starting from 2 to n, as we have this taken 4 in this case. So until we reach 4, we will find out place gross cost of g of 2 comma vertex 1 vertex minus 1 and this k which we have considered. So um, and this is the formula to solve it. So now we will continue from g of 2 comma 3. So uh, as we have until here we have solved the gross cost uh, by considering only single vertex. So from here on we'll be considering uh, um, through we'll be considering through uh, two vertices and then reaching 1. So from 2 we can go either to 3 or 4, which are the remaining vertices. So likewise we will find the cost of 2 and 3, cost of 2 3 from, that means from 2 to 3 plus the gross cost of the um, remaining path, that is 3 comma 5. So similarly we can, as you can observe, cost of 2 of 3 is 9, which we will take it here, and gross cost of 3 comma 5 is 6, as we have calculated over here. So we will substitute all those values and then we will find the summation. Similarly we will find for 2 to 4, and similarly from 3 to 2, 3 to 4, and all these possible sets. So then we'll be calculating the gross cost of from through 3 of the vertices. So um, as we are calculating from 3 of the vertices, we can go, we have the option as a 2 or 3 or 4. So we'll be having 3 values, and similarly we will have the remaining vertices which we have calculated earlier. So then we will calculate the minimum of these values using the formula, of course. So after calculating all these values, individual values, then we will come to the main equation. We will substitute those values over here, and ultimately we will get the answer as in this case 35. So this is how we solve using dynamic programming. Okay, this might be a little confusing as this is the paperwork of solving the problem. So let's uh, get into the program to understand. Okay, uh, here we have the program in which through which we solve this problem. So let's start from the first line itself. So here we'll be importing this java.util.star. As you all know, at this point, uh, as we use java.util.star, we will get all the library values. Okay, so let's get by line. So we'll declaring integer values as n, which we will use for um, store uh, the value which is the number of vertices which we are considering. Then we'll be declaring one integer two-dimensional array uh, to store the adjacency matrix of the uh, graph which we are considering. So similarly, we will have a string to store the path in which we have traveling in each case. So we'll be considering the another integer value called number of paths, uh, which will initialize for 0, uh, uh, as it is clear that initially the number of paths will be 0. So we'll initialize it as 0. So let's get straight into the main method. So inside the main method, initially we will call the read method, where we'll be basically um, reading the number of vertices and the cosmetics here. Then we um, will be intaking the okay, we'll be declaring the array called set, uh, which we will use later to know yeah, uh, which uh, which will use to store the vertices which are traveled. So for that purpose, we will use this set uh, set array. So as we know that as we are starting from the vertex 1, so we will initialize set of 1 as 0, as we are starting from the vertex 1. So we will print the time assessment problem result is. So here we will print the least possible value which we need. So for this, then for to print the result, the value of the result, we will call SolveTSP, that is as you can see here. So we will be calling the SolveTSP method by passing these parameters as one and set. At this point, the set array will be having as we have declared over here, the value of index at index 1, it will be 0, and all the other remaining indices will be made 1 by using the for loop. So this set array will be initially having at the first index 0, and at all the remaining indices it will be having 1. So this will be the set array, and this is what is this one which we have passed here. So in order to see that, as we reach here, we will, as you can see, we'll be having one string of path sequence in which the sequence in which we are passing in this path. So that's what it is. So as we are starting from the vertex 1, we will take it initially as 1. So that's what we are passing over here. So after we call this, in the SolveTSP function, we will be calculating, let's consider this for loop. This for loop will count the number of vertices which we have visited by using this set array. So as we go through the loop, we'll get to find the number of vertices which we have visited or not visited similarly. So then after calculating the value count, if the value is count, we'll be considering it as we have reached the end of the path. So of course, if the count is 0, that means we will be making 0 when we have visited a vertex, right? So when we have reached all the vertex, the count value will be 0. So at that point, that's obvious that we have reached the end of the path. So that will be one particular path. So the path we will assign this path sequence at this particular point of time. So what is this? Then why are we incrementing this number of paths? So this number of paths, as I said earlier, we will be initializing it as 0, and later onwards, it will be incremented to 1, and as we reach another paths, so that will be incremented with the number of paths which we will be getting. So that is why we have took it as static, so that if any update in the number of this number of path value, that will be remain unchanged. So then we will return the cost from that end vertex, that is as we have reached the end of the vertex, to the first vertex, as we are traveling back to the initial vertex. So if this is the case, if the count value is 0, then what else if count value is not 0? It might be 1, 2, or however, whatever, depending on the number of vertex we have given. So then we at the else part, we will take the for loop, which we will start from I value 2. Why I value 2? Again, the same answer. As we are starting from the vertex 1, we'll be starting from vertex 2. So we will be go on running this for loop, incrementing it until we reach all the vertices. So then inside the for loop, we have the condition, if condition. What will this if condition do? If this if condition will check. Basically, it will check if I value is not equal to k. So what is k? K is the value which we have passed here, that is the particular vertex which we have passed. So is the vertex equal to k? If it is equal to, then if the condition, then the if condition will fail. So nothing will happen in the in this particular this particular part of the loop. So then we will go to next value, incremented value, that it will be next possible value. So similarly, if in the set array, if the set the value uh, in the ith index of the set array, if it is 0, that means we have already visited that array. So in that case also will not be going further. So the same repeats, and nothing happens uh, in this part. So then we will increment height, and it will uh, go on happening. So if both the conditions satisfied, then we will set the the index at ith position at 0. That means we have not visited this vertex, right? So then we will make that vertex as visited, and as we will calculate the value from that particular position, and we will call this SolveTSP from this value uh, by passing the set at this particular position. And then we'll be updating the path sequence uh, the, with will be joining for which we'll be joining the particular right vertex in which we are present. So next, after calculating the value, if this value is less than the minimum value, which will be initially took it as a very large value, possibly any value, will be taking it. So if the value is less than minimum, then we will make that value as minimum. We will assign that minimum value, that to minimum value. So next, after this condition is checked, then we will again mark that vertex as we have completed this. We will again mark that as not visited, and we will continue with the another possible vertex. So this is how we will solve this particular method. Then we will call the method called find path. What will happen at this method? So basically, in this method, we'll be assigning will be required two integer values, that is minimum index and minimum value. Okay, which in this will initialize as a minimum value as higher value and minimum index as 0. So we will start from I equal to 0, and we will go on incrementing until the number of paths which we have got at the end of this SolveTSP method. And, as number of paths is not reached, then we will go on continuing through this loop. So initially the path cost will initially test 0. So and pre-value and k-value as 1. So we will first as the at this particular point of position, we will split the path into separate separate. We will separate this using a string tokenizer, and we will separate this path of I, and that is if we have to path of 1, for say for example. So path of 1 might be we might take it as a 1 to 2, 1 to 2, 2 to 3, 3 to 4, to 4 to 5, and then 5 to 1. So we will break it into separate parts, where we will break it at when we have this symbol, arrow symbol, then we will break it at this particular point. So then as you know, until it has more tokens, we will be continue to break the token. Token means this path, this particular path, and we'll be using k is equal to integer dot parsing. Why integer dot parsing? Because in this particular path, with this we have taken it as a string, but we need it as the integer value of here. So we will continue. We will take it as the integer to convert it as an integer from a string. We will use integer dot parsing of the next token which is available. So we will get this k value, then we'll update the path cost value, and then we will update the pre value as the uh, current current value of the k. So after after traveling through all these uh, uh, after traveling throughout the path, then we will start from then we will update the path cost value with the as we have reached the end of the path. Then the path we will be considering it as 1 to 2 to 3, 3 to 4, 4 to 5. So that will the end vertex will be 5. But we have to return to 1 again, right? So we will add the cost from the end vertex to the initial vertex. So that is what happens at this particular line. Then we will consider if condition in which we will compare the path cost with the minimum value, which initially will be a greater value. So the path cost of the initial path will be assigned to minimum value, and the minimum index as 1 at the first iteration. Similarly, this will, as we go through the follow-up in as we go on, then the minimum value for each path will be checked and it will be updated over here. And as we reach the end of the follow-up, we will be getting the minimum value of the all the path cost of the available paths. So as we get it, we will um, we will link that part to from end vertex to 1 again. So over here, we will then after attaching this to the um, path, we will print it as the path is the path which which we have finally got. So this is all what happens in the program. So let's run this program and check. Okay, I'll consider, I will give the input as the same graph which explained before earlier. So I will enter it as number of vertices 4 and the cost matrix which I have took in that particular example. So I will enter this cost matrix, and as we can observe, we got the same result 35. So a particular program uh, is solved, and the path in which we will get to 35 is from 1 to 2, 2 to 4, 4 to 3, and 3 to 1. So this is the result. Okay, so now the question is, this is about the output, but what happens at what happens exactly in this answer we have got? To understand that, let's let's get to know. Okay, we will understand in detail through this PowerPoint presentation. Okay. Uh, as we observed in the program, initially we will call this uh, SolveTSP uh, SolveTSP method with the values 1 and set of 1. Initially, as I said, the set um, array will be having the values 0 and all the remaining ones. So at this particular point, as we can see, the count is 3. So which happens at this particular follow. So as we can see, count is not equal to 0. So hence we will go to the else part. As we go to the else part, we will start from the I value is equal to 2. When we take value is equal to 2, here the k value is 1. So obviously this is not equal to 1. So this condition is satisfied. And similarly, set of 2 is also not equal to 0. So both conditions are satisfied. Then we will make the set of I, which is 2, as 0. Then we will update the value of this. We will update the value as C of k comma I, which is 1 and 2. C of cost of 1, 2 plus. Then we will iteratively call SolveTSP. Sorry, not iteratively. We will call SolveTSP by passing the values as this particular value I in which we are at this present stage, which is 2, and we will pass the set which is changed as 0, 0, 1, 1, as we have made set of 2 is equal to 0. Then this particular set will be passed with the path sequence will be updated as the present path which is there, and we will link that path to the this particular I value, so from 1 to 2. So we are knowing what is the cost of 1 to 2, which is cost of 1 to 2 is as you can see over here is 10. But what is the value of what happens at this particular TSP of 2 comma set comma 1 comma 2? Let's find it over here. So we will find it out separately. Okay. As we can see at this particular point, the set array will be 0, 0, 1, 1. Okay. And that's what the set value is at this particular stage. Then as we are calling this SolveTSP at each time, then the minimum value will be made 999 at each time we call it. So now, as we can observe, the count value is 2. So this for will return count value is equal to 2. So as it is not equal to 0, it will go to the else part of the this method. So at the else part, then the for loop will begin from I value is equal to 2. So at the I value is equal to 2, then 2 will be equal to k, which is 2 over here. So this particular condition will fail. And also set of 2 is also 0. One of the case, if one of the case is failed, then nothing will happen over here. As both these conditions are failed, then nothing happens at this particular I is equal to when I is equal to 2. So then I value is incremented to 3. When I is equal to 3, then I is not equal to k is satisfied, and also set of 3, as you can see, it is 1, so not equal to 0. So here set of 3 will be made to 0. Okay, so set of 3 is made to 0. Then we will update the value as a cost of ki, which is 2, 3, and we will add this SolveTSP by calling the SolveTSP method here, in which this particular time we will call 3 comma set comma from 1 to 2, which will add the link to the third vertex. So as you can observe here, the set value will be 0, 0, 0, 1. And the cost of 2 to 3 is 9, which we have to go here. But what is the value in this particular value? Again, we will consider another one for that. So what we need, 3 comma set comma 1, 2, 3, right? So here we have that. Okay, here we saw that. Again, when we are solving this when we are calling that this method once again, so freshly, then num will be again started with 999, and at this particular stage count will be 1, which is again will lead to the else part of the for loop. At this point, when we start from 2, then I value is not equal to k, but set of 2 is equal to 0 over here. So nothing will happen. The I is equal to 2 iterate. So then when we come to I value 3, I value is infinite and we'll come to 3. At when I is equal to 3, then I value is equal to k. So clearly at this point part of the for loop also nothing will happen over here. Then I value is incremented to 4. At this point for I is equal to 4, this both the conditions are satisfied, that is I is not equal to k, 4 is not equal to 3, as we can see over here, and set of 4 is also 1. So both the conditions are satisfied, and we will continue through this if condition. Then we'll make a set of this set array at the fourth vertex, which in which we are present as 0, and that is we'll make that as visited, that particular address, that particular vertex as visited. Then we will update the value. Here k and I values are 3 and 4. Then we will call SolveTSP again, in which we are passing 4 and set at this particular point it will be all zeros, and we will add the link from the present path sequence to the ith vertex. As you can see, for a cost of 3 and 4 will be 12. We have option, but what is this value? So again we will consider another part over here. So what is what do we need? So TSP of that is SolveTSP of 4 comma 6 comma 1 1 2 3 3 2 2 2 2 4. So this we will this one 1 to 2 2 to 3 3 to 4. This one, this value is what we require right now. So we will call it again. At this particular point, the set value will be all zeros. So as it is all zeros, um, uh, the count value will become zero. As the count value is zero, then we will proceed with the if condition itself. And we will, at this point, we have reached the end of the uh, this path. So we will as we have came to know that we have end of the path. This is the one particular path which we can travel. So we will increment the number of path value which is which was initially zero. As we increment, it will become path of one. As you can see, path of one. So path of one will be assigned with the path sequence at this particular moment, which is 1 to 2, 2 to 3, and 3 to 4. And we will return cost of at this end point, which is k, which is 4. Cost of 4 to 1 we will return. So this will be returned over here. Over here. So what did we return? We returned 8, right? So value of 8 is we will get over here. So the value which we will get is 20. So is 20 less than minimum? Yes. 20 is less than minimum, which is 999. So minimum value will be updated at this particular point. Then as the minimum value is updated, this condition is satisfied. So then we will make again the set of 4 is equal to 1. That is, we will consider that if 4 is not traveled, what is the another remaining path? But we don't have another path, right? That is what happens at this for loop. As we have reached end of the for loop, at this particular point, if I value is incremented, it is greater than n. So the for loop ends over here. So as the for loop ends, after the for loop ends, then the else part is over here. Then after we reach the end of this, we will return the minimum value at this particular position. That is the SolveTSP of 4, 3, 1 to 3 is completed. So we will return that minimum value from where this TSP of 3, 1 to 3 is called. That is, the minimum value is 20. So this minimum value is returned to here. So at this particular point, we will add this these two values, and we will get, which we will get as 29. One minute. Okay. Now the value will be 29, which is clearly less than the minimum value at this point, which is 999. Then as this value is compared, then the minimum value is then changed to 29. But this is not the end. We will yes, we will update the set value over here as well. Then after this happens, uh, the for loop at the I value is equal to 3 is completed. Then we will go to I value is equal to 4. Again, at this, the same repeats. The set of 4 will be beat to 0. The value of k comma at this point, which is 2 comma 4, we will consider, and we will add the we will call this TSP method again from this particular ith value, 4 comma set comma 1 to 4. So what will this particular, what happens in this particular, okay, is 4 comma set comma 1 to 4. Here again, as we call this, the minimum value again will be updated, and as we can see over here, as we had made set of 4 is equal to 0, then set of as the set at this set array, the is updated with 0 0 1 0, which is called over here this point. Then count is 1, so which is not equal to 0. Then we will continue to else part. The else part, for I is equal to 2, the set of the set value will be 0. So we will proceed to for I value is equal to 3. But I value is equal to 3. Both conditions are satisfied again. So we will make that set value as 0, that is visited, the vertex is visited, and the value we will update with the k comma I, that is cost of 4 3, which is 9, and we will call TSP at this particular right position, and will bypassing the set value, which is all zeros, and to this part 1 to 4, we will join this side value again. So 1 to 2, 2 to 4, 4 to 3. So here we'll get this as 9. But what is 3 TSP of 3 comma set of 1 to 4 3? So this as we have passed the set value with all zeros, the count value will be 0. So again, this happen, this if condition will proceed. So here the path of number of path which was previously 1 will be updated to 2, and the path sequence is assigned to this second path. Then we will return from this kth value to initial vertex 1, which is from 3 to 1, which is 6. We will return at this over here, which is 6. So 9 plus 6 is 15. So 15 again is again with minimum value, which is 9, 9 and 9. So which is minimum. So minimum value is updated as 15 over here. Then we will again make that particular vertex as visited is 1. Set of 3, we will make it as 1. Then for I is equal to 4, then here the condition will fail as I value is equal to k. So all the iterations are completed. So we will come out of this for loop, and which will end the else condition, and this particular position only return, we will return the minimum value, which is at this particular position 15, from where this TSP of 4 comma set comma 1 to 4 is called. Okay, we have written 15 over here, which will be updated as 25 now. And now this will be compared with the previous minimum value, which was 29. So is this 25 less than 29? Of course it is. So the minimum value will be updated to 25. And again, over here, the set value which was which we took as 0. Again, we will make it as not visited, and we'll check for the for loop. At this particular point, we have reached end of the for loop. So else part will be finished. Then we will reach this line, return minimum. So minimum value 25 will be returned from to where say 2 comma set of 1 to 2 is called, which is over here. So ultimately, the minimum value 25 is passed over here. Okay, as we have returned 25 over here, then the value will be 35, which will be compared with the previous minimum value, which was 999. So, which is clearly less than the minimum present minimum value. So then minimum value will be updated, and this set of two will again made as visited, and we will consider another path, which is when if we go through the vertex 3, so which will continue with the for loop as at I value 3. Again, we will make it as 0, and we will get the value. uh, we will update the value by using cost of 1 to 3 plus calling this TSP of 3 comma 6 comma 1 to 3, uh, which will be calculated over here. Here, then again, minimum value is updated. And then at this point, the set value is uh, count value will be 2 for this particular set. Then we'll proceed to else part, and then by considering I is equal to 2, we'll check the if conditions, both if conditions are satisfied. So we'll make it as 0. The value is updated over here, and cost of 3 to 2, which is 13. We will add with the TSP of 2 comma 6 comma 1 to 3, 3 to 2. So what is TSP of 2 say 2 comma 6 comma 1 3 2? So okay, we are passing set value 0 0 0 1, right? So we will we can, as we can observe over here, we have passed the set value 0 0 0 1, and then again it will start from here, then the minimum value will be again made high, and at this particular point, as we go through the for loop, we will get count value as 1. So again, count value is not equal to 0, it will go to the else part. And then else part will start from for I is equal to 2. For I is equal to 2, which is equal to k. So this then we will increment, and then nothing happens here, and we will increment I value. Then we will reach I is equal to 3. When I is equal to 3, again set of 3 is 0 here. So again nothing happens. Then again I value is incremented to 4. When I value is equal to 4, both the conditions are satisfied. So we will proceed inside this if condition. So over here, we will make a set of 4 as 0. And again, we will update the value with the cost of k comma, which is 2 4 over here. And we will add the TSP value of set 4 comma set comma 1 1 2 3 3 2 2 will link with the particular ith value 1 2 3 2 2 2 2 4. So which we will get 1 2 3 2 2 4 over here as again as count is equal to 0. We'll increment the third path available over here, and then we will return the uh, cost from end vertex to the initial vertex, which is 8, from where it is called. So here it will return 8. So it is added with the previous means cost of 2 to 4, which we have taken. So then value is again updated, and it is compared with the previous minimum value, which is clearly uh, minimum, so which is clearly lesser. So we will update the minimum value as 18. So again, we will make it as visited, and we will proceed to check if other iterations are possible. We will be at the end point of the follow. So we will this condition will be will end, and we will return the minimum value, which is 18 to from where it is called, from 1 to 3 3 to 2. Okay, the 18 is returned over here. So again it is updated, and which this is compared with the previous minimum value, which is 999, and so again minimum value is updated, and again we will make it as not visited, and um, then the set array will be reset to 0 1 and 0 0 1 0 1. Then we'll proceed to for I is equal to 3. For I is equal to 3, k value is equal to I. So nothing happens over here. Then we will go to I is equal to 4. When I is equal to 4, again the set of both conditions are satisfied, then we will make a set of 4 as 0. Then we will add then we will update the value cost of 3 to 4, which is 12, and we will add it to TSP of 4, which is I value 4 comma set at this particular point, which is 0 1 0 0, and we will pass the sequence 2. So then we will reach 4 comma set comma 1 2 3 to 4. So again this one is called, then again minimum value is updated, and then count value will be checked, and it will be 1. So it will go to else part. Then again our for loop is start from 2. Again this both the conditions are satisfied, and set of 2 will be made to 0. Then all full set array will be made 0. Then again we will update the value with the uh, cost of the k comma, which is 4 to 2, which is 8, and we will add this to TSP of 2 to 2 comma set comma this path to link to this will be called. So this will return, as we can see over here. This is called, and the set value will be all made to 0, and then again as count is equal to 0, and then path number of paths is incremented, then path of 4 will be this path, and we will return the cost from end vertex to the initial vertex, which is 5, from where it is called. So 1 2 3 to 4 to 2. Until here we have reached, we have got 4 possible paths. So 1 2 3 to 4 to 2. This will return 5, right? So again the value will be updated, which is clearly minimum than lesser than the previous minimum value. So minimum value is updated to 13, and again set of 2 will be made to 1, which is not visited, and we'll check for the further if any of the uh, iterations is possible. So when I is equal to 3, the set value will be 0, and when then as we increment for I is equal to 4, then I value is equal to k. So uh, all the for loops are completed. Then else it will come out of the else, and then the minimum final minimum value is 13, which is returned from where this 4,6, 1 to 3 to 4 is called. So so 13 is written over here, 12 plus 13 is 25, which we will compare to the previous minimum value, which is available over here. So 31. 25 is clearly less than 31, right? So the again minimum value will be updated to 25, and then a set of this 4 will be again made 1, so which will be made not visited. And then we will check for further loops at the, if any possible over here. As we have reached end of the for loop, so we will return minimum, which is 25, from where this one is called, from 3, set, 1 to 3. So this one is called over here. So 25 is written over here. So 40. At this particular position, the previous minimum value over here is complete. Is 40 less than 35? No. This is greater than 35, right? So this if condition will fail. So minimum value will remain as 35 itself, and the set of this particular vertex 3 is setting me to 1, and set value will be updated. So then we'll proceed further. Then we'll increment the ith value, and we will come to what now, vertex 4. At the I value is equal to 4, again set of 4 is made 0, and the value will be updated by calling 4, set, 1 to 4. When we reach 1 to 4, again minimum value is made higher, and count value will be 2. Then we will go to else part. Then for I is equal to 2, again we will start from I is equal to 2, which will in which both the cases are satisfied. Then we will update this set array as for set of 2 to be 0. So then again we will update the value again. We will make it as a cost of 4 to 2 plus TSP 1 to 4 to this particular right position 2 again. So 142 is again called. So which will again where again minimum value is made higher, and this particular position count value will be 1, so it will go to else part. Then we will start with for I is equal to 2. Now I is equal to 2, it is equal to k, right? So then nothing happens. So then we will reach to for I is equal to 3. When I is equal to 3, both conditions satisfies, so we will make it as 0, that is we will be visiting this vertex, and then again this continues with the we will updating the value. Then the 3 of set of 1 to 4 to 2 to 3 is called which will return 6, which is the end of vertex is 3, from 3 to 1, which is value 6, it will be returned, and the path number of path is incremented to 5, and the 5th path is recorded as this particular path, and this 6 value is returned to is returned over here. 6 values returned. So then both the values added, and which is compared with the previous value, which is lesser than the minimum value. So minimum value is updated to 15. Then again, this set of 3 is made to 1. So when then we'll go to 4, but set of 4 is 0. It is 0 at this particular position. So uh, nothing happens at this point of for loop also. Again, then we will return the minimum value, which is 15, from where this one is called 1 to 4 to 2. So 15 is returned over here. So which is updated and compared with the previous minimum value. Again, this is lesser, so minimum value is updated. And again, a set of this is made as again not visited, and we'll proceed for further for loop. Then we will, as 2 is completed over here, and then 3 is checked next at this path, and then set of 3 is again made to 0, and value will be updated by calling this TSP of 3 comma set comma 1 to 4 to 3. 1 to 4 to 3, then again minimum value will be made higher. Then count will be 1 at this particular stage. Then we will go to else part. Then we will make this for loop start from for I is equal to 2. Both conditions are satisfied, and we'll proceed further. Then we will update the value with the cost of ki plus then solve TSP of 2 comma set comma 1 to 4 to 3 to 2. This is called again 1 to 4 to 3 to 2. Again, the set value is 0, which will indicate that we have reached end of the another path. So here it will be here it will update the uh, sixth path, and it will return the value from end path to the end vertex to the initial vertex, which is 5. So 5 is written over here. Then again, the minimum value is checked, is updated, and again it is made as visited, not visited. Then we'll proceed for I is equal to 3. Then I will be equal to k. So this will fail. Then for I is equal to 4 is 10. For I is equal to 4, the set of 4 will at the fourth position will be 0. So for all the for loops are completed, the at this particular position minimum is 18, which is returned from where this 1 to 4 to 3 is called. So it will return 18 over here. So then we will cost of 4 to 3 is added with this 18. So at this point the minimum value will be 27, but the previous minimum value is 23, which is not lesser than 23. So as it is greater than this if condition is failed. So minimum value will remain as it is. Then again set of 3 will make it as 1, and at this point the minimum present is 23, which we will return from where this TSP of 4 comma set comma 1 to 4 is called. So 23 is written over here. So 20 and 23 it is calculating, which is 43. So 43 is again compared with the previous minimum value available, and again which is greater. So minimum value will remain unchanged again. So set of 4 will be made 1. Again we'll check for further loops, but all the iterations are completed. So the minimum value is returned as 35 from where this TSP of 1 comma set comma 1 is called, which is at the main function. So finally the minimum value 35 is returned to the main function. So this is how the SolveTSP method works. So then what exactly happens at the find path? So at find path, we will start from minimum value will be again made higher, the minimum index will be 0, then we'll start from y is equal to 0, but so we but as we are taking from path of 1 2 3 4 and I is equal to 0, which we have not updated any value, so um, so uh, this we won't consider right now. So then for path of 1 we will start from over here. So when I is equal to 1, um, the path of 1, and this is this is separated, broken into separate tokens. Then 1 to 2 to 3 to 4, and this will be separated at the point at this particular point. And we 1 2 3 and 4 are separated individually. At the first point, this while loop will break and get the k value as 1. So then when 1 is got, we will increment this path cost with the previous path cost, which we have initialized as 0. So the screen share, okay, sorry.